The following message has been brought to you by the Mile High Flood District. Hi, I'm Dave Skoutis, Watershed Manager at the Mile High Flood District. A hydraulic feature we often use along our urban waterways to keep them stable is something called a drop structure. A drop structure is very intuitively named. It drops the flow from a higher elevation down to a lower elevation. This drop can create very turbulent hydraulics, so it necessitates a pretty robust structure, hence the name drop structure. Drop structures flatten slopes and slow down velocities for the channel upstream, which improves stability. Here are a few examples of drop structures of various shapes and sizes. They invariably get built with some combination of rock and concrete because they need to be built to last. When drop structures fail, they are very expensive to fix. In this video, we'll be introducing you to an important drop structure component called the Seepage Cutoff wall, or cutoff wall for short. Here is a profile or side view of a typical drop structure. The water on the surface drops down and over the structure. Besides the surface water that we physically see, there is also groundwater that we don't see. So when we use the term seepage, we're talking about the slow movement of groundwater through voids between the soil particles. With inadequate seepage control, two failure modes get introduced. One failure mode is seepage pressure. Even though the surface water drops down over the structure, the groundwater doesn't necessarily drop along with it. With inadequate seepage control, the uplifting pressure can be large enough to either break apart a structure or completely flip it over, as was the case in this photo. This structure was installed without a cutoff wall. The other failure mode is subgrade erosion. In this situation, the water disappears beneath the structure where it starts to erode the subgrade. As water flows beneath the structure, it eventually finds a weak spot and pops back out from underground. This creates a void under the structure that eventually caves in. Here are a few video clips to demonstrate what that can look like. Notice the toilet bowl effect where water enters the subgrade, a pothole where we can see water flowing underneath the structure, and then where it pops back out from underground. So cutoff walls reduce seepage pressure and prevent subgrade erosion. Cutoff walls should be located upstream of the drop structure crest. They can be constructed of sheet pile, grout, or concrete. Grout and concrete both get used in cutoff walls the same way, so consider those terms interchangeable for the rest of this video. Here you can see the typical subgrade excavation for a grouted boulder drop structure with a sheet pile cutoff wall. Here is the sequence of setting the boulders, driving the sheet pile, grouting the structure, and then placing riprap upstream. The cutoff wall can also be hidden between a row of boulders like you see here, as long as it's upstream of the crest. For concrete drop structures, the cutoff wall is typically situated like you see here. One of the most important construction details involves the connection between the cutoff wall and the rest of the structure. Regardless of the materials being used, there needs to be a continuous overlap of material between the drop structure and the cutoff wall because the most common seepage failure occurs at this connection. Even a small gap can lead to the seepage pressure and subgrade erosion I mentioned earlier. For sheet pile, we like to see a minimum of 12 inches of grout overlapping the sheet pile in the upstream direction both horizontally and vertically. There should be at least 6 inches of grout on the downstream side to complete this connection. Grout cutoff walls are ideally poured monolithically with the grout for the rest of the structure. When a grout cutoff wall is poured separately from the rest of the structure, a substantial keyway needs to be formed in the top of the cutoff wall, usually accomplished with a 2x4. The second grout pour needs to overlap the cutoff wall by at least 6 inches on the upstream side, both horizontally and vertically. Because of the keyway, we don't need an overlap on the downstream side. The connection should be completely buried to eliminate the unattractive view of the cutoff wall and to provide a more effective seal. The goal is to keep flow on the surface. Another component that alleviates seepage pressure is the weep drain. The taller a structure gets, the more important weep drains become as an added protection measure. They get installed at 10-foot centers and are required whenever a drop structure is 5 feet tall or taller, but they could be necessary for smaller structures depending on site conditions. Weep drains consist of clean aggregate encapsulated in filter fabric with 3-inch PVC pipes to discharge water through to the surface. The pipes stick out like this during construction so they don't accidentally get grouted in. They get cut flush after the grout sets. Proper inspection during construction is vital, so we'll be posting other videos that go into much greater detail about what to look for when inspecting either sheet pile or grout cutoff walls. And of course, it's also important that cutoff walls be designed to the proper depth and width to adequately cut off any groundwater seepage. Please consult the district's criteria manual for design guidance. Make no mistake, inadequate seepage control will result in erosion and channel instability, leading to expensive repairs we'd like to avoid through proper design, construction, and inspection. I hope you learned something from this introduction to cutoff walls. Thanks for watching.